Welcome to VIZ Studio, your go-to channel for 3D visualization tutorials, tips, and industry insights. Have you ever wondered how those stunning realistic images in movies, video games, and architectural presentations are created? The answer is 3D rendering, and by the end of this video you will understand exactly how it works. In this video, we will take a deep dive into the world of 3D rendering. We will cover what 3D rendering is, how it works, which industries use it, the most popular tools available, and how you can get started. So what exactly is 3D rendering? 3D rendering is the process of converting 3D models into 2D images or animations using specialized software. Think of it as taking a virtual photograph of a scene that exists only inside a computer. The software calculates how light interacts with the objects, materials, and surfaces in the scene to produce a realistic image. This process involves complex mathematical calculations including ray tracing, global illumination, and radiosity. The end result can be a single still image, a sequence of frames for animation, or a real-time interactive experience. The 3D rendering market is valued at over $5 billion in 2025 and is growing at nearly 20% per year. Let us understand how the rendering process works at a high level. It all starts with a 3D model, which is a mathematical representation of an object in three-dimensional space. The model is then given materials and textures to define how its surface looks, including color, roughness, reflectivity, and transparency. Next, lights are placed in the scene to illuminate the objects, just like a photographer would set up lighting in a studio. A virtual camera is positioned to define the viewpoint and angle of the final image. The rendering engine then traces millions of light rays through the scene, calculating how they bounce, reflect, and refract off every surface. The final output is a photorealistic image that can look almost indistinguishable from a real photograph. Before we go further, let us understand some key rendering concepts. Ray tracing is a technique where the software traces the path of light rays from the camera into the scene to determine what each pixel should look like. Global illumination simulates how light bounces between surfaces, creating soft, natural lighting with color bleeding between objects. Ambient occlusion adds subtle shadows in corners and crevices where objects meet, adding depth and realism. Subsurface scattering simulates how light penetrates translucent materials like skin, wax, or marble. Depth of field blurs objects that are closer or farther from the camera focus point, mimicking how a real camera lens works. Motion blur adds a streak effect to moving objects, making animations feel more cinematic and natural. Understanding these concepts will help you create more realistic renders as you develop your skills. Let us look at the different types of 3D rendering. There are two main types of 3D rendering: real-time rendering and offline rendering. Real-time rendering generates images instantly, typically at 30 to 60 frames per second. This is used in video games, virtual reality, and interactive applications where the image must update in response to user input. Modern game engines like Unreal Engine 5 and Unity have made incredible progress in real-time visual quality. Offline rendering prioritizes image quality over speed. Each frame can take seconds, minutes, or even hours to render depending on the complexity of the scene. This type of rendering is used in movies, TV commercials, architectural visualization, and product design. Software like V-Ray, Corona Renderer, Arnold, and Keyshot are all offline renderers. The 3D rendering pipeline is a step-by-step workflow that every 3D project follows. Step 1 is modeling, where you create the 3D geometry of your objects using software like 3ds Max, Blender, or Maya. Step 2 is texturing, where you apply materials and textures to give your models realistic surface properties. Step 3 is lighting, where you place lights in your scene to create the desired mood and atmosphere. Step 4 is camera setup, where you position the virtual camera to frame your shot. Step 5 is rendering, where the rendering engine processes all the data and produces the final image. Step 6 is post-processing, where you enhance the rendered image using tools like Photoshop or Corona Image Editor. Each step in this pipeline is critical to achieving a high-quality final result. Now let us explore which industries rely on 3D rendering. Architecture and real estate is one of the largest users of 3D rendering. Architects use 3D rendering to visualize buildings, interiors, and landscapes before they are constructed. This helps clients understand the design, make decisions, and approve projects with confidence. Real estate developers use rendered images and virtual tours to market properties that are still under construction. High-quality architectural renders can make the difference between winning or losing a project bid. Interior designers use 3D rendering to present furniture layouts, material choices, and lighting schemes to their clients. This is the field where VIZ Studio specializes, creating photorealistic architectural visualizations for clients worldwide. The film and entertainment industry uses 3D rendering extensively. Visual effects in blockbuster movies like Avatar, The Avengers, and Jurassic Park rely heavily on 3D rendering. Everything from realistic dinosaurs to entire alien worlds is created using 3D modeling and rendering techniques. Animation studios like Pixar, DreamWorks, and Illumination use rendering to create entire animated feature films. TV shows, streaming content, and commercials also use 3D rendering for special effects and product placements. The demand for 3D artists in the film industry continues to grow every year as content production increases. The gaming industry is another massive user of 3D rendering technology. Modern video games feature incredibly detailed environments, characters, and effects that are all rendered in real time. Game engines like Unreal Engine 5 support advanced features like Lumen for global illumination and Nanite for high-detail geometry. These technologies allow developers to create cinematic-quality visuals that run in real time on consumer hardware. The gaming industry generates over $180 billion in revenue annually, making it one of the most profitable entertainment sectors. 3D artists working in gaming are in high demand, especially those with skills in environment design and character modeling. Product design and automotive industries also rely heavily on 3D rendering. Companies visualize products before manufacturing, saving time and money on physical prototypes. E-commerce companies increasingly use 3D product renders instead of traditional photography because they are more flexible. A single 3D model can be rendered from any angle, in any color, and in any environment without a photo shoot. Car manufacturers like BMW, Mercedes, and Tesla use 3D rendering to design vehicles and create marketing materials. Online car configurators where you customize colors and wheels are powered entirely by 3D rendering. The medical and scientific fields use 3D rendering for visualization and education. Doctors use 3D rendering to visualize organs and anatomical structures for surgical planning. Pharmaceutical companies create molecular visualizations of drugs and proteins using 3D rendering. Scientific researchers visualize complex data sets, from weather patterns to astronomical phenomena. Educational institutions use 3D rendered content to create interactive learning materials and simulations. Here is a summary of how different industries use 3D rendering. As you can see, architecture, film, and gaming are the three largest markets for 3D rendering. But product design, medical, and automotive are growing rapidly as technology becomes more accessible. The total market across all industries is expected to reach over $25 billion by 2034. Now let us look at the most popular 3D rendering software available today. VIZ by Chaos is one of the most widely used rendering engines in the world. It works with multiple 3D applications including 3ds Max, SketchUp, Rhino, Maya, and Cinema 4D. VIZ uses a hybrid rendering approach that can leverage both CPU and GPU for faster render times. It offers advanced features like adaptive lights, a powerful material editor, and VIZ Vision for real-time previews. VIZ is the industry standard for architectural visualization and is used by studios and freelancers worldwide. It has a steeper learning curve compared to some alternatives, but the results are exceptional. Corona Renderer, also by Chaos, is known for being the easiest renderer to learn and use. It is designed primarily for architectural visualization and interior design. Corona is purely CPU-based, which means you do not need an expensive graphics card to produce stunning results. Key features include interactive rendering, light mix for post-render lighting adjustments, and a built-in denoiser. The latest version, Corona 14, introduces AI material generator, Gaussian splats, and a night sky system. If you are just getting started with 3D rendering, Corona is an excellent choice because of its ease of use. Arnold by Autodesk is the default renderer for many film and animation studios. It uses a physically based approach and is tightly integrated with Maya and 3ds Max. Arnold is known for its stability in production pipelines and supports both CPU and GPU rendering. Octane Render is a GPU-based renderer known for its speed and real-time preview capabilities. It produces beautiful results and is popular among freelancers and creative artists. Keyshot is a standalone renderer designed specifically for product visualization with a drag-and-drop workflow. Blender Cycles is a free and open-source rendering engine that has become increasingly competitive with commercial tools. Each of these renderers has its own strengths, and the best choice depends on your specific needs. Let us compare these renderers side by side. VIZ is the most versatile, supporting the widest range of 3D applications. Corona offers the best ease of use and is purely CPU-based. Arnold excels in film production with its deep integration into Autodesk products. Octane and Cycles are excellent GPU options, while Keyshot is perfect for quick product renders. One of the most common questions in 3D rendering is whether to use GPU or CPU rendering. CPU rendering uses your computer processor. It is slower but handles complex scenes with heavy geometry and materials better. GPU rendering uses your graphics card, processing many calculations in parallel for much faster render times. However, GPU rendering is limited by the memory on your graphics card. Very large scenes may not fit in GPU memory. Some renderers like VIZ offer hybrid rendering that uses both CPU and GPU together for optimal performance. CPU-only renderers like Corona eliminate the need for expensive graphics cards, which is a significant cost advantage. For beginners, CPU rendering is a safe choice because it works on virtually any modern computer. As your skills and budget grow, investing in a powerful GPU can dramatically speed up your workflow. Let us talk about the hardware you need for 3D rendering. For CPU rendering, invest in a processor with many cores. AMD Ryzen 9 or Intel Core i9 are excellent choices. RAM is critical. Start with 32 GB at minimum, but 64 GB is recommended for serious work. For GPU rendering, NVIDIA RTX series cards are the most widely supported. The RTX 4080 and 4090 offer excellent performance. Storage matters too. Use an SSD for your operating system and projects, and a large hard drive for file storage. A good monitor with accurate color reproduction is essential for evaluating your renders. You do not need to buy everything at once. Start with what you have and upgrade as your needs grow. Let us talk about career opportunities in 3D rendering. 3D rendering skills are in high demand across multiple industries. As an architectural visualization artist, you can work with architecture firms, real estate developers, or as a freelancer. The average salary for a 3D visualization artist ranges from $50,000 to $90,000 per year depending on experience and location. In the film industry, you can work as a texture artist, lighting artist, or compositor at major studios. Game studios hire 3D artists for environment design, character modeling, and technical art roles. Product visualization is a growing field, with companies constantly looking for artists who can create photorealistic renders. Freelancing is also a viable option, with platforms connecting 3D artists with clients from around the world. The key is to build a strong portfolio that showcases your best work in your area of specialization. If you are new to 3D rendering, here is how to get started. First, choose your 3D software. Popular options include 3ds Max, Blender, Maya, and Cinema 4D. Blender is free and open source, making it an excellent choice for beginners on a budget. Next, pick a rendering engine. For architectural work, we recommend Corona Renderer or V-Ray. For product design, try Keyshot. For animation and film, consider Arnold or V-Ray. Start with simple scenes. A basic room interior or a product on a table is a great first project. Watch tutorials, practice daily, and study real-world lighting and materials to develop your eye for realism. Most importantly, be patient. 3D rendering is a skill that takes time to master, but the results are incredibly rewarding. Here are some tips to help you create better renders. Always use reference images. Study real-world photos of the materials and lighting you want to recreate. Pay attention to scale. Objects that are the wrong size instantly break the illusion of realism. Use 3-point lighting as a starting foundation. A key light, fill light, and rim light work in most scenarios. Do not oversaturate your materials. Real-world surfaces are usually more subtle than you might expect. Add imperfections. Real objects have scratches, dust, and wear. Adding these details makes renders more believable. Use post-processing wisely. A little color correction and contrast adjustment can take your render from good to great. Render at higher resolution than needed. You can always scale down, but you cannot add detail to a low-resolution render. Practice consistently and compare your work with real photographs to identify areas for improvement. That is a complete overview of the world of 3D rendering. If you found this video helpful, make sure to subscribe to VIZ Studio for more tutorials on 3D rendering and visualization.